Hi, Honors Algebra. This is section 5.3, and we're going to be talking about dividing monomials. And they are going to be using dividing monomials and polynomial functions. So right now we have the warm-up. If you could pause the video and try these on your own, because this is something that's reviewed to you. All right, welcome back. Hopefully you did try these on your own. And remember, when we're simplifying, with numerics in front, we're just going to do exactly as the operation says, which is divide our numerics. So negative 28 divided by 12 here is reduces to negative 7/3. Here, when we have variables with bases is the same and we're dividing, the rule is to, with our friend up here helping us, subtract the exponents. When we subtract those, we're going to put that answer, the remaining answer, wherever the exponent is greater. So we have x to the second in the numerator. Here, remember, this is y to the first, and y to the first divided by y to the third. Again, we're going to subtract those exponents. Since our power is higher in the denominator, we're going to subtract it downstairs in the denominator. So we have y to the second. And there you go. That's it. None of the other terms are alike, so that's our final answer. All right, here we're going to simplify. We're basically just going to take this monomial 4x squared and distribute it to every single term in the next set of parentheses. And again, just multiply the numerics. 4 times 6 is 24. X squared times x cubed, multiplying bases are the same. You add those exponents, leaving us with x to the 5th power. 4x squared times negative 4x squared is negative 16x to the 4th power. And 4x squared times 2x is positive 8x cubed, because 1 times 2 is 3. We add those exponents. 2 plus that 1 is x cubed. So this is our final answer. We do not have any other like terms, leaving us with that final answer. All right, well, actually, before we talk about dividing and simplifying, I want to mention we are able to distribute this 4x squared to every single term. And the nice thing about division is working backwards, they're inverse operations of each other. We're going to actually do the same. So if you notice, this trinomial on top is being multiplied by this monomial on the bottom. Because it's a monomial on the bottom, we're actually able to apply and divide this 4x squared by every single term in our numerator. So it gets applied to all 3 terms. So I know that looks like a mess, but I just wanted to show you how we can actually take each of those terms and divide each of them individually by 4x squared. So rather than leave it very messy like that, what we want to do is we could rewrite each and every term and divide it by that monomial of 4x squared. So if we just rewrite them as separate fractions individually, then it'll work out and it'll be a lot easier. And again, this only works with monomials. So here we're taking 6x cubed divided by 4x squared, and 6/4 reduces to 3/2. But again, when we're dividing and bases are the same, we're going to subtract those exponents, and we're going to subtract it and leave wherever the numerator, wherever the power is higher, which in this case is the numerator, so 3/2 x. And look here, anything divided by itself is just going to be 1. So we have -1. And then 2 divided by 4 is 1/2. And then we are dividing, bases are the same. We're going to subtract the exponents wherever the power is higher and leaving that x to the first. So I know that kind of looks strange, but that's our answer. All right, same thing here. This is a monomial. We're dividing this trinomial by a monomial. So we can actually take each individual term and divide it by that 6ab squared. So if we take the time to just write that out and divide each of them individually by 6ab squared, this will be a lot easier to deal with. All right, well, numerics, we're just dividing. 12 divided by 6 is 2. A cubed divided by a to the first. Again, subtract those exponents. A squared on top. B to the first divided by b squared leaves us with subtracting 1b left over in the denominator. This looks like it's going to be 1, but it's really not, because just the numerics are 1 here. We we have a 1, and then we have a, we're subtracting on top, and we have 1, we have no b's on top, so actually 0 divided by, we have b squared in our denominator, and then negative 18 divided by 6 is 3, and we have no a's to subtract from on the top, so that a is still left over in the denominator, and the b squareds are gone. 2 minus 2 is 0, so the b's are taken away. So this is our final answer for problem B. All right? So far, so good. And now what I want to do is introduce synthetic division. Well, the nice thing about synthetic division, I think you're actually going to like this. There's 2 rules we have to follow. Synthetic division, it's like a shortcut in that we only can use our degree in our denominator. Our degree in our denominator is to the first power. Well, this x is to the first power, this b is to the first power, and this n is to the first power. So we're good to use it. And the second rule is you can only use when your leading term, which is your leading term here, x is our leading term, when your leading coefficient is 1 as well. In other words, if this were 2x plus 2, or 4b minus 1, or 3n minus 3, we could not use this. So notice our leading coefficient in every example here is 1. We can use this, and our degree is also to the first power, so we can use synthetic division. So I'm just going to erase that. Alright, so the first thing we're going to do is figure out what would make this denominator 0. Whatever is going to make this denominator 0 means that our function would not exist. So in this case, we know we can't divide by 0. So what would make this denominator 0 is if we had a negative 2 in here for x. So what we're going to do is we're going to put a negative 2 in this strange little box. I like to call it the DJ box here. And with synthetic division, we're going to be doing 2 operations. We're actually going to be adding straight down, or we're going to be multiplying on a diagonal. And that's it. So I'm going to show you right now, if you look in our numerator, we have leading terms here, and it has to be in descending order, and it has to go down by a degree of 1 every single time. So all we're going to do is we're going to take our coefficients, which are our numbers in front of those variables, and we're going to bring down those coefficients, grabbing the sign and all. And we're going to make a little equal sign here. Now, the first thing we're going to do, always bring down that first term. So 2 plus 0 is still 2. And now on a diagonal, according to what I told you before, we're going to multiply. So negative 2 times 2 is negative 4. And we're going to put that right here. And now we're just going to add straight down. Negative 5 plus a negative 4 is a negative 9. And then on a diagonal, we're going to take that number. Negative 2 times negative 9 is positive 18. And here we're going to add straight down. Negative 3 plus 18 is positive 15. And we're going to put this answer in that little box here. This is actually a remainder. Now, if you look, if I go ahead and erase these little coefficients here that we first brought down, I want to mention that, I want to mention that what we started with in our numerator was 2x squared. And when we're dividing by a power of 1, that means our answer is going to be 1 degree less. So we're going to end up with an x term, or a linear term. These are actually the coefficients that we started with from our numerator. And here, these are the answers of our coefficients to our actual quotient. So that means this, and this are the coefficients to our answer. And 1 degree less from what we started would be 2x, and then minus 9, which ends up being our constant, and this is our remainder. So because it's our remainder and it's positive, we're going to put plus 15, but do not put a remainder of 15, and it's plus 15 over whatever we divided by, which is x plus 2. So this is the answer, or our quotient, to our actual problem that we started out with. Let's try this one. Notice here in this one, we go from b to the third to b to the first. We can't skip that b squared term. So if you need to, I want you to always think about and fill in which each of those terms are. So if we think about our DJ box here, what's going to make this denominator 0 is if b were 1. So over here, I'm going to put a 1 in there. Now our coefficients, we have to make sure we fill everything in. So sometimes we have to come up with a filler. This coefficient is 1, so we're going to put a 1 there. B squared, well, I don't have any b squareds, so I have to put a 0 there. I need that filler. B to the first, well, that means I have a negative 4. That's my exponent. And b to the 0 means it's just my constant. So sometimes, you know, b to the 0 is just my constant term. So right here, what I really want to put is just a number. So my number, which is just my constant, is going to be, in this case, positive 8. All right? So here, bring down your equal sign. I'm going to add straight down, so 1 plus 0 is just 1. On a diagonal, I'm going to multiply straight across. 1 times 1 is 1. Here, I'm going to add straight down, so this is 1. 1 times 1 again is 1, and it's a positive, and negative 4 plus 1 is negative 3. And I'm going to multiply on that diagonal. 1 times negative 3 is negative 3, and add straight down. 8 plus negative 3 is 5. All right? So, because we started out with b cubed, that means our answer is going to be 1 degree less. Since we're dividing by b to the first, we know we're going to get an answer of b squared. In this case, our coefficient is 1 as well, so we get 1b squared plus, since it's positive, 1b minus 3. That's our constant. And since this is our remainder, it's going to be plus 5 over b minus 1. So this is our answer. Okay? All right. Last but not least, all right, so we have n to the 4th minus 6n squared minus 13n. We do jump. Notice we don't have any n cubes, and notice we don't have a constant. So we're going to have to fill those in. So over here on the side, just think about n to the 4th, n cubed, n squared, n to the 1st, and then our number, which is just our constant. So our n to the 4th term we have is a leading coefficient of 1. Our n cubed term, we don't have one. We're going to have to fill that in. N squared is negative 6. Our n to the 1st is negative 13. And we have to fill that constant in. All right. So I'm going to write those again over here so you guys can see this better. And what's going to make our denominator 0 would be a positive 3. So let me just change the color of that. So if I put positive 3 in for n here, all right, and then I put these coefficients, 1, 0, negative 6, negative 13, and 0, and make my equal sign. I'm now going to bring down my first term. 1 plus 0 is 1. 3 times 1 is 3. 0 plus that 3 is 3. 3 times 3 is positive 9. Negative 6 plus 9 is positive 3. Actually, I don't need that positive there because it's implied to be positive. All right. All right, and then I'm going to do 3 times that 3, which is positive 9, and then negative 13. I'm just waiting for this to get out of the way. All right, so we have negative 13 plus 9, which is positive 4, and then 3 times 4 is 12, and 0 plus 12 is 12. All right, so let's see. Actually, we have a negative 4 here, not positive. Just realized that. So that means this is a negative 12 here, which makes a remainder of negative 12. All right, so our final answer, again, if we started out with n to the 4th power dividing by n to the 1st, we know we're going to get n to the 3rd. So it's always going to be 1 degree less. So this is our leading coefficient of n cubed plus 3n squared plus 3n minus 4, and then this is our remainder, minus 12, all over n minus 3. All right, so this is the end of the lesson for 5.3. So now you have your 5.3 day 1 assignment. Thank you.